Today we're going to talk about section 10.2, which is our introduction to polynomials. So as we get started, the first thing that we're going to look at is a definition of the word polynomial. So a polynomial in X is a finite sum of terms of the form ax to the nth power, where a is a real number and n is a whole number. Usually the sum is written in descending exponential order. Right, well, just looking at this, there's a lot of different words in here. It's kind of a complicated mathematical definition. So we're going to go through and dissect what all of these different parts mean and see if we can figure out what a polynomial actually is. Right, so the fact that it's a polynomial in X means that we're using X as our variable. It's a finite sum of terms. It's a finite sum of terms means that there is a certain number of terms that we have. We might have one term, we might have two terms, we might have three terms, four terms, right? But all of our different pieces, right, are terms that we can actually pick out and we can count. And it's finite means it does not go on forever. Right? Our terms are the form ax to the nth power, where a is a real number and n is a whole number. What that means is that all of our terms, since we're in a polynomial in X, right, we're going to have X as a variable, and then our number out front is going to be a coefficient, right? And that coefficient out front is a real number, so it could be anything. It could be a positive number, it could be a negative number, it could be a fraction, it could be a decimal. Right? So our coefficient can be pretty much anything, but our exponent, our n, has to be a whole number. Right? So what we have here in our definition for polynomial is we have a list of terms that are being added or subtracted together in order to give us our entire complete polynomial. Our sum is written in descending exponential order, means that generally when we look at polynomials, our largest exponent is going to come at the beginning of our expression, and then our thing, if we just have a number, our constant term, that's going to come at the end of our expression. All right, so in other words, polynomials are expressions that contain terms with variable parts that have only whole number exponents. Right? So our coefficients can be anything, but our exponents are only whole numbers. Each term of the polynomial includes the sign, the coefficient, the variable, and the exponent. We've talked about terms already. We've talked about like terms. Right? So that's what we're thinking about here. We're thinking about these different pieces being our terms. Sometimes they might be like, sometimes they might be unlike. A polynomial can consist of one single term or the sum of two or more terms. Right? So polynomials can come in different sizes. A polynomial may not have a variable in the denominator or within a radical being a square root sign. Right? So we're not allowed to have variables in denominators or any variables inside square root signs here. Polynomials are often written in descending exponential order. Again, we mentioned that in the definition above. Right? So as we're writing out our answers, right, we're generally going to put our term with our highest exponent first and then work our way down to our smallest one. An expression with the fewest number of symbols is said to be in simplest form. Right? So that means in some cases we're going to see instructions that mean simplify, which means we're going to take our problem and make it look as nice as possible. All right, so now that we've defined polynomial, we want to talk about three different types of polynomials. So a monomial is a polynomial with one term, the prefix mono meaning one. Right? A binomial is a polynomial with two terms. Right? Just like a bicycle has two wheels, a binomial, prefix bi meaning two terms. A trinomial has three terms. Right? Just like a triangle has three angles. Right? So our prefix tells us how many terms we have. If we have more than three terms, then we just call it a polynomial, because the prefix poly actually means many. So anything more than three terms, we're just going to refer to as a polynomial. So in this first example down at the bottom of the page, we're going to practice using some of these terms and definitions. We're going to fill in this table. We're going to list all of our terms separately, and then we're also going to identify the type of the polynomial that we have. So our first polynomial is 12z squared plus 4z. Notice that we are in descending exponential order. Our larger exponent is first. And notice that we have two pieces of our sum here. So our terms are this 12z squared and this 4z, and we're just going to separate them with commas. Our type, well, two terms means we have a binomial. Right, 8a is just one single term. One single term is a monomial. Right. X squared plus 5x minus 3, we have three terms here. X squared, a positive 5x, and a negative 3. That sign is going to go with our term. Three terms means we have a trinomial. Negative 7 is one single term. It doesn't happen to have a variable, but that's okay. It's still considered a monomial. X squared minus 7x cubed minus 3x plus 1. This one is not in descending exponential order, so if this was an answer for one of our problems, we're generally going to want to rewrite it. But looking at this, if we were to list out our terms, right, we have an x squared, a negative 7x cubed, a negative 3x, and a positive 1. Since we have more than three terms, we have four terms. Right? And this is a polynomial. In our next one, our terms are negative 2 over w and positive 3. Right? Going back up here, remember that we were told that a polynomial may not have a variable in the denominator or within a radical. So what that means is because we have this variable in our denominator here, right, this w causes a problem for us. This one is not a polynomial. Now if we compare this to this last one here, our term is 3/4 b squared. Notice that our variable is off to the side, right? We just have a number in our denominator. That's allowed, right? This is still a monomial. So we can have fractions as coefficients. We're not going to run into many, maybe one or two problems for the entire chapter. I'm going to choose to put fractions as coefficients in there. So for the most part, we don't have to worry about it. We could have decimals out front too. So again, you might run into a couple throughout the entire chapter that have fractions or decimals. We're not going to focus on that, but it is just something that we want to mention because you may run into it at some point later on down the road in another math class. Right, so as we're thinking about polynomials, we're classifying them by the number of terms that they have. Right, if we're asked to list the terms, we're going to separate them using commas, and then we can then identify the type of polynomial that we